Hi everyone. Today we're going to be looking at how to reveal the hidden b value for a transformed absolute value function. So in your notebook, please put today's subtitle, which is Revealing the Hidden b in the Absolute Value Function. We're going to begin this lesson by first looking at what the rule of a transformed absolute value function looks like when it's written in proper format. It could look like one of these two. Notice that the one on the left does not have the b value visible. That's because the b value can actually be absorbed into the a, which many textbooks do. And when the b value is not absorbed into the a, that's when it is actually visible, such as shown on the right. Either way, the presence of b doesn't really impact on anything. The vertex is still revealed by h and k, and the opening of the graph, whether it's a right side up v or an upside down v, is still revealed by the sign of a. Now, the big question is, why are these two rules considered quote-unquote proper format? Well, they're considered proper format because of the following reason. The x has a coefficient of positive 1 on it. So at this point, you might be asking yourself, what is an example of an absolute value function that's not written in proper format? Well, how about this as an example? Y equals negative 2 times the absolute value of 3x plus 6 plus 4. You will notice very quickly that the coefficient on the x is not 1. In this example, it's actually 3. So how do we get rid of that 3 from the x? It's actually quite easy. All you have to do is use the common factor technique to factor out that 3 from the expression 3x plus 6. Observe. So we have y equals negative 2, absolute value of, and we're going to use the common factor technique to factor out the 3. And the final result from using the common factor technique is we have x plus 2. And the plus 4 has never changed. Observe. Now the coefficient in front of the x is 1, and at the same time, and more importantly, the value of the true h has been revealed. Alright, let's try another example together. Suppose I asked you to rewrite this in proper format. Y equals 3 times the absolute value of 2 times 5x minus 10, and then plus 9. Alright, let's apply our common factor technique on the 5x minus 10. So y equals 3 times the absolute value of 2, and let's factor out the 5. So the 5 comes out of the bracket, so we have times 5, and inside the bracket, the result of the common factor technique will give us x minus 2. And then the plus 9 has always been there. And one final cleanup process. Y equals 3 times the absolute value of 2 times 5 is 10. And the bracket x minus 2. And then plus 9. So the value of b has been revealed to be 10, and the true value of h has been revealed to be 2. Alright, let's do one final example that I'd like for you to try on your own. What if I asked you to rewrite the following in proper format? Y equals negative 4 times the absolute value of 6 times, how about half x minus 5, and then the k value is plus 8. So go ahead, I'd like you to pause the video and try it on your own now. Alright, let's see how you guys did. So I'm going to perform the common factor technique on the half x minus 5. So that will give me y equals negative 4 times the absolute value of 6 times, so factor out the half, that'll give us half, and the remaining result of the common factor technique gives us x minus 10. And then the plus 8 doesn't change. And one final cleanup, we have y equals negative 4 times the absolute value of 3 multiplied by x minus 10, and then plus 8. So the true b has been revealed to be 3, and the true h has been revealed to be 10. And that's all there is, ladies and gentlemen, to factor out the b in the absolute value function.